Good afternoon. We are going to do notes for 7.5, Theorems for Similar Triangles. Now, in the previous section of notes, we learned about angle similarity postulate. So we're just going to continue to add on to that with other types of theorems that let us prove similarity without having to do all the angles and all the sides. All right, Theorem 7.1, side angle side similarity theorem. Here's an abbreviation for it. It says if an angle of one triangle is congruent to an angle of another triangle, and the sides, including those angles, are in proportion, then the triangles are similar. Okay, so looking at these two triangles, we need one angle that is congruent. So we're going to say that angle A is congruent to angle D. Angle A congruent to angle D. And then we have to prove that the sides are proportional, which means that the sides have to reduce to the same ratio. Now, sometimes it's handy to have some notation so that you can tell which sides go together. So side AB, we're going to use a single P for proportional with side DE. And then side AC, two P's, and side DF, two P's. So A and D are our congruent angles. So we need to prove that the sides on either side of them are proportional. So we're going to say that the ratio of AB to DE, the single P's, is equal to the ratio of AC over DF, which is the double P's. If we can prove those two things, we can say, therefore, triangle ABC is similar to triangle DEF. All right, so let's use this. If, let's say AB equals 18, so let's say this one's 18, and DE equals 20, what is the scale factor of ABC to DEF? Now, when you do scale factor, if they don't show you original and new, you go in the order they're given. So first triangle given over second triangle. In other words, it goes this way. So on the first triangle given, AB was 18. The second triangle given, DE was 20. So we reduce those. Let's see, 18 is 2 times 9, so 2, 3, 3. 20 is 4 times 5, so 2, 2, 5. We can divide out a 2, and we're left with 9 over 10 as the ratio. That is the scale factor or the ratio of the sides. Now that we know that, what is the scale factor of triangle DEF to ABC? So if we flip around the order, so DEF comes first, the scale factor is the same, it's just flipped. It'll be 10 over 9. All right, Roman numeral 2, Theorem 7-2. This is side similarity theorem. Really important to put that similarity symbol in there. Otherwise, side by itself means congruency theorem, which is different. Okay, here it goes. If all three sides of two triangles are in proportion, in other words, they reduce to the same fraction, then the triangles are similar. All right, so we've got triangle ABC and triangle DEF. So in this theorem, you have to be given matching sides are proportional. So let's mark them before we write them. AB is the smallest side, DE is the smallest side, BC is the medium one, EF is the medium one, and AC is the longest, DF is the longest. So we can clearly see which ones go together. So here we go. AB, short sides, AB over DE is equal to medium sides, BC over EF, which is equal to long sides, AC over DF. If we can show that those three ratios are the same, that means they are in proportion. And our conclusion is then triangle ABC is similar to triangle DEF. And after you've proven similarity, of course, this is not, you can't use CPCTC because that's only for congruent triangles, but you can say that corresponding angles are congruent, and that would be by the definition of similar triangles. So we can get the angles out of this, just not using CPCTC. Okay, so let's do an example. The measures of triangle ABC are 4, 5, and 7. So let's mark that. 4 for the little one, 5 for the medium one, 7 for the long one. And the measures of triangle XYZ. Okay, we don't have XYZ, so we're going to draw it here. Obviously, these numbers look bigger. So we're going to draw a nice big triangle that looks as similar as we can make it. Short side, medium side. There we go. And this is X, Y, Z. So the sides of XYZ, now, if they put 16, 20, and 28, you always go in order of the triangle statement. So 16 is XY, 20 is YZ, and 28 is X to Z. There we go. They want to know if the triangles are similar. Okay, if the triangles are similar, all three ratios of sides should turn out the same. So what we need to do is take and make the ratio of sides from triangle ABC over triangle XYZ and see if they're the same. So we're going to have a ratio of the small sides, the medium sides, and the large sides. All right, let's do this. The smallest side on the first one is 4. The smallest side in the second one is 16, so 4 over 16. Medium sides are 5 and 20. Large sides are 7 and 28. Notice I'm not putting equal signs because we don't know if they're equal yet. We want to reduce these and see what we come up with. So 16 is 4 times 4. So 4 will divide into 4 one time, and we get the ratio 1/4. Okay, now we do the mediums. 20 is 4 times 5. The 5s divide out, and I get 1/4 as my ratio. And the last one, 28, is 4 times 7. The 7s divide out, and I get 1/4. So the answer to the question is yes. Triangle ABC is similar to triangle XYZ. If they ask you to explain or give a reason why, we would say side, 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 triangle, similarity, theorem. All right, flip the page. All right, we're going to do some more practice. 7.5 practice. Here we go. In triangle ABC, it gives us a small side 2, a medium side 5, and a large side 6. In triangle XYZ, the small side is 2, the medium side is 2.5, and the large side is 3. Is ABC similar to XYZ? So we're going to do side, side, side again. So small sides, medium sides, large sides. And we're going to do first over second, ABC over XYZ. So the small side is 2 over 2. The medium side is 5 over 2.5. The large side is 6 over 3. Now just looking at this, I can tell that 2 over 2 is going to be 1. 6 divided by 3 is 2. So those two don't match. They are not equal. They're not the same ratio. So our answer would be no. The triangles are not similar. If we were asked to give a reason why, we would say the sides are not proportional. Be sure you use the word proportional. We're not talking equal, we're talking proportions. Okay, number 2, x, y, q. And I left off the q. The q is here, the p is here. If x, y, q is similar to x, z, p, does it follow that x, p, q is similar to x, z, y? Okay, we need to draw these triangles out. X, y, q is this one here. So let's draw that one. Okay, that's x, that's y, that's q. And then we're going to draw the other one, x, z, p, x, z, p. Okay, so identical triangle looking, just pointed the other way. And that is p, x, z. Okay, if those two are proportional, okay, so if these two are proportional, small sides, medium sides, long sides, 3p's. Okay. Does it follow that x, p, q, which is the small one, that's x, p, q, is similar to x, z, y, which is the large one? Okay, so we know that xp on the small one is proportional to xq, but those are on the same triangle. Yes, they are proportional to each other on these triangles, but when comparing the little one to the big one, those are only on the little triangles. Another proportion we can get, let me change colors here, x to y, so this whole length here is the long side, x to z is the long side. We know that those two sides are proportional with each other because they're the long sides of these two. The problem is that these proportionalities don't compare the little one to the big one. Those two are on the same triangle, the big one. Those two are on the same triangle, the small one. So are they proportional? The answer would be no. And the reason would be that there is no relationship between the sides of triangle XPQ, the small one, and triangle XZY, the big one. We can't find any relationship between those, so as far as we know, that's not similar. All right, example number 3. Name similar triangles and give the postulate or theorem that justifies your answer. Okay, so we have a little triangle here, and then we've got the big triangle on the outside. We have one angle, 80 and 80, but also the two triangles share this top one. So angle A is congruent to angle A, and that would be reflexive property. And we already know that these two are similar. So there's two angles. So angle, angle, similarity, postulate would mean that they are similar. Okay, so what would our statement be? Little triangle ADE similar to big triangle ABC. And that would be our justification. All right, let's look at B. Name similar triangles and give the postulate or theorem that justifies your answer. Okay, well, again, we're dealing with the little triangle here, and then the big triangle, which is here. So we have a triangle in a triangle. We know that both of those share angle C, so that's easy. So angle C is congruent to angle C, and that would be reflexive property. So we do have a theorem, side, angle, side, but to prove it, you have to show that the sides on either side of the congruent angle are proportional, meaning they reduce to the same ratio. So if I go small over big, small side is 6 over big side, which is 6 plus 3, that's 9. We want to know, does that reduce to the same ratio as the other two sides? The small one is 10, the big one is 10 plus 5, which is 15. That's the question. Well, 6 is 2 times 3, 9 is 3 times 3. Lose a 3, we get 2/3. What about the other one? 10 is 2 times 5, 15 is 3 times 5. Lose a 5, we get 2/3. So yes, they have the same scale factor. So we can say that triangle CDE is similar to triangle CAB because of side angle side similarity theorem. That would be our reason, just like that one. All right, let's do C. Okay, we have two triangles and we have all their sides. So we can see if they're similar by side, side, side. We're going to do a ratio of small sides, a ratio of medium sides, and a ratio of the long sides. So we'll go little over big. Little side on the little triangle is 3 over little side on the big. Now this is 6 and that's 10. This side is 6 plus 6, which is 12. So smallest one is 6. For the medium side on the small one, it's 5. Medium side on the big one is 10. Long side of the small is 6. Long side of the large one is 12. 3 over 6 is 1/2. 5 over 10 is 1/2. 6 over 12 is 1/2. All of them reduce to the same ratio or scale factor. So we can say that triangle KLM is similar to triangle, we've got to go in order, KON. And the reason would be side, 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 triangle similarity theorem. All right, last thing we're going to do. Actually, this one goes with this one, sorry. If triangle ABC, number 4, is similar to triangle DEF, does side AB correspond to DE? Does BC correspond to DF? So in a similarity statement, corresponding sides are the same pattern as a congruency statement. So if this is AB, then it would correspond to DE because of the order. So that one's a yes. If this is BC, it should correspond to EF. So this one is a no. And if they asked for a reason, you would say BC corresponds to EF. The order matters. All right, number 5, given angle B congruent to DEC, that one, prove that ABC, which is the big triangle, is similar to DE, I think that's supposed to be DEC, because there is no F. So we're going to have to call this DEC, which is the little triangle. There, yep, fix that. Okay, we have one angle congruent. So just looking at this, remember that the little triangle here and the big triangle, which is here, share one angle, which is angle C, and that will give you angle, angle. Okay, so let's do a proof about that. First, you do your givens. So number 1, angle B is congruent to angle DEC. That was given to us, so given is the reason. Number 2, we have to say that angle C is congruent to itself, angle C, by reflexive property of congruence. Now remember, there's two properties of congruence. two properties that are reflexive. There's a property of congruence, and there's a reflexive property of similarity. So here on out, you got to be a little careful which one you're referring to. Okay, so now we've got both triangles, so we can say step 3, triangle ABC is similar to triangle DEC because of angle, angle, triangle, similarity postulate. Now, on your homework, they're going to want you to go one step further. After that, they're going to ask you to prove angle A congruent to angle EAC. They might not even tell you to prove the triangles. They might just tell you to prove that A and should be A and EDC. Oh my goodness, my notes are terrible. So A and EDC. So we would want to prove that those two are congruent to each other, which we can do after we prove the triangles are congruent. So if that were the proof, our fourth statement would be angle A is congruent to angle EDC, and that would be the definition of similar triangles. Remember, there is no CP/CTC for similarity. That only works for congruency. So once you've proven similarity, then you can use the definition of similarity to get all the other parts that you don't have. All right, that's all for the notes today. Have an excellent afternoon.